Hello, this is the next video in a series I'm calling Transformations of Random Variables. In this video, we're going to look at a uniform distribution, and when we transform it, it goes to a Cauchy. And then we have a couple other examples. We actually go from a Cauchy back to a uniform also. So here, let's let x equal a uniform distribution from minus pi over 2 to pi over 2. Let y equal tangent of x and z equal sine of x. And we want to find the distributions of f of y and f of z. So let's start with y first, and if we graph the transformation, x of course is uniform in this range, and the tangent of x ends up being this. And those are vertical asymptotes, so it's all real numbers. Y equals tangent of x. Back solve for x, we get arctangent of y. This is the density or distribution for x, it's just 1 over pi. The Jacobian, we take the derivative of the arctangent of y, we get 1 over 1 plus y squared. Now, this derivative, I'm not going to go into detail, but I'm going to point you to a video that I created called Derivatives of Inverse Trig Functions that explains that pretty good. So now let's find the density of y. Then we have to plug in, we use f of x, but we plug in this value that we back solve for, and then take it times absolute value of Jacobian. Well, this here, the density is just 1 over pi. There's no way to where to plug in values. And then the Jacobian is this, and it's always positive, so we can take the absolute values away. And then we're done. That's it. And this is the density for a Cauchy distribution. And so now let's look at the second transformation, Z sine of X. And if we plot it, it goes from minus 1 to 1 in this range here. So back solve for X, we get X equal to arcsine of Z. The density of X is the same, 1 over pi. The Jacobian is the derivative of the arcsine of Z, which then becomes 1 over the square root of 1 minus z squared. And again, I'm going to point you to the video derivatives of inverse trig functions for this calculation. Now notice that z ranges from minus 1 to 1, and so this is always positive. So now let's find the density of z. We plug in arcsine of z into f of x. The absolute value is Jacobian, and the 1 over pi is this piece. The Jacobian is 1 over square root of 1 minus z squared. And again, z ranges from minus 1 to 1. If we were to plot this, it looks like this on the 0 to minus 1 to 1. So that's it. That's the density. So now one final example. We're going to start with a Cauchy distribution. X is a Cauchy, and the density is this, 1 over pi, 1 over 1 plus x squared. And we're going to look at the transformation arctangent of x. And now we want to find the density of y. And so if we were to plot this, now x ranges from, it's the real number line because it's a Cauchy. It goes, the negative infinity to infinity. And if we plot the arctangent of x, it is this, and it limits to pi over 2 to minus pi over 2. Those are actually horizontal asymptotes. So now when we back solve for x in this equation, we get x is equal to the tangent of y. Now we take the derivative of the tangent of y, and we get secant squared of y. So that's our Jacobian. And then to find the density of y, we plug in what we back solve for, tangent of y, into the density of x, which is the Cauchy. Take it times the Jacobian, which is secant squared of y. And so here is the density of the Cauchy, and we need to plug in this to the x squared, so we get tangent y squared. And then this is the Jacobian. Well, there's a famous trig identity, 1 plus tangent squared of y is actually equal to secant squared of y. So let's replace that, and then those cancel. And then we're left with just 1 over pi on this range from minus pi over 2 to pi over 2. Well, that's a uniform distribution. And so we went from a Cauchy to a uniform distribution with that transformation. Well, that's all I have for today. Hopefully you enjoyed it. If you did, please like the video and subscribe so you don't miss the next one. Thanks. Bye.